Hey guys, in this video we're looking at properties of exponents. This one has tons of examples, but they're pretty quick little problems, just lots of flavors. So this first round we're going to look at the first three properties. This first one goes, when you're multiplying things with exponents, you add the exponents. And a nice way of thinking of this, if you just think of like what x squared and then x cubed would be, it's really x, and then x, right? 2x's, 3x's. You count them, that's 5x's. And so we can just say 2 plus 3 makes 5. So that's kind of how this property is working. This next one is going to be when we raise to a power. And so the one I like to use for this is x squared cubed. And if you think about what that really is, that'd be x squared, which gives you 2, 4, 6 x's, or x to the 6th. So if I just go 3 times 2, there's my 6. But that's kind of why that one works. And these two are really easy to mix up. When I was a student, what I used to do when I couldn't remember which was add and which was multiply is I just write these two down, and I could kind of look at this and go, okay, 1, 2, 3, 4, 5 x's, okay, 3 sets of 2, 6 x's. And I could kind of reason it out. This third one here, this is a lot like property 2. It's just a to the first, b to the first. So we're going x times 1 for x times 1 for x. So this is really just an extension of this one. It's also showing that if you have an exponent outside parentheses, it belongs to everything in those parentheses. Okay, so let's look at some examples. This first one, so this is referencing property 1. It's multiplying, so we're just going to add our exponents. And this right here, a little bit sneaky, that's this little thing over here, which is when it's just a plain variable like that, in this case a or x, doesn't matter, it's really a to the first, so this is really like x to the first. So then I got 12 plus 6, 18, that would be 12, so x to the 30th. This next one is more like property 2, because you can see there's parentheses and we're raising something to an exponent. So this means 3 of these. So if you think about that, it's negative 2, negative 2, negative 2. So that's going to be a negative 8. You can also kind of do a little interim step where you write it like that. But you have to be careful with the parentheses. I would just think of what it really is, which is 3 negative 2 multiplying, and that gives us a negative 8. And then here, this would be 3 times 4 would be x to the 12th. That next one, this is going to be, so this is like 3x to the 4th twice. Didn't space that very well, so I'm going to come up here with it. So that is going to be, let's see, 3 squared will give us a 9, and then x to the 4th squared, so 2 times 4 makes 8. So that's this piece. And then this and this, there's nothing in there, so it's like a multiply. And then this would just be 5 times 4, x to the 20th. And then I still have x's in more than one spot, which means I can keep going. And if you look, it started off as kind of property 2, and now it's turning into property 1, where I have a couple things multiplying. And so this would be 8x's and 20x's makes 28x's. And number 4 here, so again, you can think of this squared. I'll write this one out. It maybe makes the fractions a little bit easier. But that's all that means. And so there's your double negative, so it'll be a positive. 5 times 5 is 25. We can also just say negative squared is going to be positive. 5 squared is 25. 3 times 3 is 9, so 3 squared makes 9. And you can see here I'd have 3x's here, 3x's here, which would make 6. And x cubed squared, 3 times 2, same 6. Okay, this next round in a lecture section, I would have you guys try them. So here, I was a little bit sneaky. So notice I have x's here and I have y's there. So I got to do like terms. So x's go with x's. So 2 plus 6 would give me x to the 8th right there. There's an invisible 1 on that y, so there's 1 here, 8 there. And that would be y to the 9th. Let's see, this one, this is going to go, so this is like having 2 of these, so negative 5 would make 25, and then x to the 6th squared will be x to the 12th. Number 7, so it would be 1, 2, 3 negatives, so I think negative 2/3, negative 2/3, negative 2/3, so it's going to be negative overall, and then 2 cubed, or 2 times 2 times 2 would make 8, and then 3 times 3 times 3, or 3 cubed, makes 27. And then x cubed cubed would be 3 sets of 3, so that'd be 9, or just 3 times 3, x to the 9th. Number 8, so this has a couple of property 2's going, so we'd go 4 times 6, because I have 6 sets of 4, so that'd make 24. Here I have 2 sets of 5, or 5 times 2 would be 10. And then 24 and 10 is going to go x to the 34, because I'm just adding those exponents. And that part was property 1. This one, so this is kind of reminding us that we got to do the square to everything. So if I wanted to write that little 1 there, I would probably just write 49. But it's the same as saying 7 squared, and then 2 times 8 for 16, 2 times 5 for 10, and then 7 squared, which is why I usually just go to the 49 and just write down the rest. And this one, kind of like this one, but now we got the numbers. And it's easy to forget the numbers. That's a pretty common error. It's like here to forget that 7 and just get wrapped up in the exponents. But so I'm thinking of that as 2 to the first, so, or just 2 squared is probably easier, so that'd be 4. X to the 5th squared, so 2 times 5 will make a 10 right there. 3 squared will make a 9, and then since there's nothing in between there, again, that's multiply. And x4 squared would make x to the 8th. 4 times 9 would be 36, and 10 and 8 will give us 18. Okay, so this next round of problems is going to work on these 3 properties. And people have trouble with property 4. And there's actually kind of an extension of this one. So this is, if I have a to the negative x, it's the same thing as 1 over a to the x. So basically, if you have a negative exponent, you can take it downstairs and it becomes positive. So something simple like, 5 to the negative 2, that would be 1 over 5 squared, or 1/25. The reverse of this is if you have 1 over negative x, 1 over a to the negative x, it's the same thing as having a to the x over 1. So basically, if it's negative upstairs, you take it downstairs. If it's negative downstairs, you just take it upstairs, and that gets you a positive exponent. And with exponents, in general, sometimes they break the rule, but in general, it's not considered simplified if you still have negative exponents in the problem. So definitely in this section, you want to rewrite everything, both simplifying exponents, so you wouldn't want to leave 5 squared, you want to make 25 there, and you can't leave negative exponents in problems. This next one, property 5, is pretty much like property 3, but with a fraction. So again, it's just saying a to the first, b to the first, so x times 1, x times 1. So it's just saying we have to do top and bottom of the fraction. Okay, number 6 is the one that I don't like. If you like this one, that's totally cool. There's more than one way to do these problems. It's kind of a matter of, do we do property 4, property 6. I like 4, other people like 6. I'll show you both versions and you can pick the one you like. With this, let me show you why with division we would subtract. Pretend I had x to the 5th over, say, x squared. So this says I subtract the exponents and I get 5 minus 2 would be x cubed, or x to the 3rd. So the top is really like 5x's, right? The bottom is really like 2x's. So in my head, I don't really do this. I just think of it as canceling. So if I have 5 up and 2 down, it's going to leave me 3 up top, or x cubed. Likewise, if I say I had, x to the 4th over x to the 5th. So then you can think, if I cancel out 4 of them, right, I'm going to have 1 left downstairs, and that would just be 1 over x. If I did the same the same problem using the property with the subtraction, that would look like, I'll just sneak over here with it, x to the 4 minus 5, or x to the negative 1. And then you still have to do the thing where you use this property anyhow. It's just going to be 1 over x, or 1 over x to the 1, but we don't usually write the 1. So for me, it's more intuitive just to cancel than it is to do the subtraction and the rewrite. The canceling works really good when there's positive exponents, and that's why, for me at least, I like property 4 a fair bit, because it's going to let me rewrite these. So let me show you some examples with those 3 properties. I just realized there's one more coming up here. A to the 0 is 1. So anything to the 0 is 1. I'm going to do a quick little thing down here to convince you. Let's say I have 2 cubed over 2 cubed. So if I just do the math, it's 8 over 8, and it's 1, right? And back here, we already figured out property 6 works, because, if I try it with x's, it makes sense. I get this would be x cubed. 5 up, 2 down, cancel, or just do the subtraction. So here, if I use the same property, I get 2 to the 3 minus 3, which means I get 2 to the 0, which means that 2 to the 0 pretty much has to equal that 1, since, those are both the same problem. So anyhow, anything to the 0 is 1 except for 0, which is undefined. Okay, so for this round, we got 5 to the negative 2, so I think I actually did that over in the examples. So it would become 1 over 5 squared. So negative exponent comes downstairs by property 4. And I just want to finish cleaning that up to 25. So we don't want to leave this like this. Even if it was 5 to the 5th, I could just throw, 5 raised to the 5th in the calculator and make that into a number. This one's 7 to the 0. That's what I was just talking about. That's going to be 1. These next two. Okay, these are a little bit tricky because they look really similar to each other. But hopefully side by side they're easier to tell apart. Here this 2 is being acted on by the negative 3. Here the 2 is not being acted on by the negative 3. So this one the exponent is only on the x, this one the exponent's on both. So remember our property is, if I have x to the negative a, I think they wrote it the other way, but so if I have a to the negative x, it's 1 over a to the x. So this would be 1 over, and a is just like this big chunk of stuff, so it's just the 2x to the positive 3. And then that's not really done because I can still kind of clean that up a little. So 2 cubed gets me 8, and then x, that's like a 1, so 3 times 1 makes x cubed. And again, if you get mixed up on the properties, just think what it really is saying to you. And that is that this is 2x, this really means 2x, 2x, 2x. So 2 times 2 times 2, there's our 8xxx, there's our x cubed. This one, all you gotta do is fix that little piece. So believe it or not, you can move the 2 and the x to the negative third independently. So this is gonna be 2x cubed downstairs, because this is 2 times x to the negative 3, which is 2 times 1 over x3, and then just multiplying, I get that. This next round would be the ones that have you try in class. So very similar to here, I would just have 1 over 4 cubed, and then 4 cubed, 4 times 4 times 4 is 64. This one, very similar to that one. So 13, and then the negative 5 is only working on that x, so x to the 5th. Anything to the 0, even if it's a chunk of stuff like that, as long as it's not 0 to the 0, anything else to the 0 is just 1, so that's a pretty friendly one. And then this one, so 5 to the 0, that would be a 1 up top, and then 5 cubed, 5 times 5 times 5, so that's going to be 125 downstairs. Okay, so this round would be me on the board again. Okay, so here we go. So there's a couple of ways to do this one. You can do the subtraction property, x to the 4, and then minus. Remember, our property was, grab this back for a second. So a to the x over a to the y, a to the x minus y. So here, the tendency is to miss the second minus. You see this negative 5 coming up, and people just write down 4 minus 5 instead of minus 5. And that's kind of where all the mistakes get made, are in that sign. So then 4 minus negative 5, that would be x to the 9th. So that's one way to think about this. It is not the way that I think about it, and I think I'm probably in the minority, but to me, I'm not the best with signs. I tend to kind of mess those up. So for me, I just look at this and I think, hey, this should really be up in the numerator, right? X to the 4th, because negative 5 downstairs, bring it up and it's a positive 5. And then I'm just basically counting. I got 4 here, 5 there, but I'm not thinking about the signs. So then I just got x to the 9. Number 20, again, I'll show it kind of both ways. So I could think of this as x to the, let me do that better. X to the negative 5, and then minus a negative 11. So that would be x to the negative 5 plus 11, or x to the 6th. Or if you think about it the weird way I do, if I have x to the negative 5 over x to the negative 11, that means both of these are in the wrong place. So in my head, I'm not doing all that. I'm just kind of flipping it over and going, oh, okay, so this should be up top, and that should be down below, because negative 5 goes down, negative 11 goes up. And if I have 11 up and 5 down, if I just think of canceling out 5 of them, I'm still going to have 6 in the numerator. So same answer, whichever way. For me, this is a little more visual, which fits my learning style. Might not be the best for everyone. If you prefer this, they're equally cool, but just pick the one that makes the best sense for you. Next one, we'd have x negative 7, and then 4 times 2, because that's raised 2, so it's a multiply, x to the 8. Again, going the subtraction route, I would have x to the negative 7 minus 8, which makes x to the negative 15. And then careful not to leave it there, it's going to be 1 over x to the 15th. For my brain, once I'm here at this x negative 7, x 8, I just think, this should be downstairs. So then when there's nothing left up top, it's just 1, x 8, x 7, and then there's my x to the 15th. Let's see here. There's a couple of things I can do with that. I think what I will do is I'm going to go negative 2 times 1. So that's going to give me 3 to the negative 2. And this time I can't just like square it in place and write 9 here, because this negative 2 means it should be in the denominator in a second. Right now I'm just going to work on the parentheses though. So negative 2 times negative 5 gives me x to the positive 10. So then when I go to simplify this, x to the 10th is fine. It's got a positive exponent. There's nothing I need to do there. But this has a negative exponent, so I need to bring that down to my denominator and then just clean it up a little bit. So x to the 10 over 9. Here, again, same as kind of what we did earlier, but now with some negative exponents making it a little bit trickier. So this is going to go 2 times 4, so that is x to the 8. 5 times negative 2, that one is x to the negative 10. 6 times negative 3, so that's going to be x to the negative 18. And again, more than one way to go here. You could flip these right now. You could combine those top ones. So say I did 8 plus negative 10. I could get a x to the negative 2 right there over x to the negative 18. And then I could do the subtraction property. X to the negative 2 minus a negative 18. And then minus negative would be plus, so that's really negative 2 plus 18, x to the 16. Another way to look at this instead of that is you could do this, and you could just flip them over. You could say x to the 18 is up top, x to the 2 is downstairs, and that kind of lets you dodge all those signs. And that's the part that, like I said, I have trouble with signs, as do a lot of people. Even if you know what to do, it's just that attention to detail piece that can get you. So 18 over 2, there's our 16 that way. And likewise, way back here, I could have done this. So I'll just bring the 18 up and bring the 10 down. And that'll give me 26 over 10, cancel out 10 of them in your mind, not on paper. But that would leave you 16 up top. So lots of right ways to go. Just trying to give you a couple of different versions, because some people do better with one, some people do better with the other. So these next 8 are the ones I would have you try in class. If you feel like you got this going, these are going to be a little repetitive, but the thing with the properties of exponents is they look really, really easy when I'm doing them, because it's all just really basic arithmetic, right? You either add, subtract, or multiply. But on the test, these are the problem. The people do tend to have some problems with these, and I think they look so easy when I'm doing them. It's easy to kind of get a false sense of security on them. So it's not the worst thing to practice, and that's why I have a fair number of practice problems in here, so people can kind of work out the bugs before they get home. So this first one, for my brain, I just think I have 5 x's up top. I have 3 of them down below. If I cancel out 3 of them, x to the second, or 5 minus 3 makes 2. This guy, you could do x in negative 12 minus a negative 8. Which would make x negative 12 plus 8, which would make x to the negative 4, which would make 1 over x to the 4th. So that's one way, and again, I don't really like that. So if it was me, I would just think negative 12 up top, negative 8 downstairs, so the 8 should be up and the 12 should be down. And that lets me do like that. And I just think of it as canceling. So if I have 8 up and 12 down, I cancel out 8. I'm going to have 4 left in the denominator. And then I don't have to mess with those negative exponents because I'm just, again, kind of doing it intuitively. 26 would go x11 and then minus negative 7. Or x to the 11 and 7 makes 18. Or my weird way, you would go x to the 11, and then this is in the wrong place, so I'm going to bring it up, which makes x to the 7th, and there's the x to the 18 also. Here would be x negative 3 minus 22, or x to the negative 25, which would be 1 over x to the 25. Or for my brain, if I have this, that means I really have this. So just the negative 3 is in the wrong spot, so I bring it down, it's positive, and then I can just count them, 22 and 3 for 25. Okay, and then this one, probably the too easy, it's hard. So it's to the negative 1, which means it's going to be, basically it's going to be that. So if I have a negative exponent, I'm just bringing it down. This is a funky way to write it though, so when we put it in the computer, we would say just 1 over 3x. 29, we're going to have 6 times 4, so it's going to give us x to the 24th over x to the 14. 24 minus 14 would be x to the 10, or just think of it as canceling. It leaves you 10 up top. So this one, there's one more property. Let me show that. And this one's kind of nice if you happen to remember it. So this is if I have a negative exponent, I can flip this over, the fraction over, and make it positive. So that means I could write this thing as x to the 5th over x cubed squared. And I could square it like that, or I could reduce first and get x squared squared, which would be x to the 4th. Most of the time people do not remember that property, so let me show kind of the other version of how to get there. Say I just do my distribute, like normal. 3 times negative 2 would be a x to the negative 6, and then 2 times 5 would give me an x to the negative 10. I could do negative 6 minus the negative 10, that would give me the 4, or I could think of it as bringing the 10 up and the 6 down, and canceling, that would still give me that 4. So like 3 different ways to get there, and they're all perfectly good. 31, let's see, x squared to the 5th, so that's an x to the 10. X to the 5th squared, so that is also an x to the 10. And then 6, x to the 6th to the 4th, so 6 times 4 would be 24. Here, maybe I'll combine those. 10 and 10 for 20 over 24. And again, you could do the subtraction. You go 20 minus 24, get x to the negative 4, and then just have to make sure you rewrite it as 1 over x to the 4. For me, again, I like just thinking as canceling, so if I cancel out 20 of these, I'd have 4 x's left down below. These next ones are just a little bit bigger problems. They may have like x's and y's instead of just x's, but they work very similar. So this first one, what I would do, rewrite this down here, x squared, y 13, 58. Gosh, that should totally be 56. I'm going to have to correct that in the notes. So that should be a 56 right there. The 7 doesn't go into 58. Okay, so now that's a 56, it's going to go 7 times 8, and then x6, y5. So I just kind of think, again, as canceling. You could write this all out as subtraction, but you'd end up with like 7 over 56, x2 minus 6, y 13 minus 5. Negative exponents, you still have to reduce and bring stuff up and down. So this is kind of where I really like the canceling version. So 7 over 7 is 1, that's gone. So I'll just bring down the 8 right here. If you think I got 2 x's up, I got 6 x's down, so if I cancel out 2 of them, I am still going to have 4 left in the denominator. And then if I had 13 y's all written out and 5 y's written out, and I cancel out 5 of them, I would have 8 up top, or 13 minus 5 is 8. This one, so we want to do a little cancel first with that 9. So 9 goes into 45 5 times. That'll make that a little easier. I think I'm going to kind of clean this numerator up and then figure out kind of what's going on. So right now, and I do have this negative down here. Negatives and denominators look kind of funny, so I'm going to start it up in my numerator. So let's see, 5 times 16, so that would be 80. Oops. And then x5 and x9, so 5 and 9 would be 14. And then that's over 17, x to the 17. And then negative 80. And I got 14 up and 17 down, so if I canceled, I would have 3 left in the denominator. Okay, and the last of this incredibly long video. So just a little bit more complicated versions of what I just did, and these would be the ones I have the class try. So this first one, I got double negatives, so I'm going to have a positive, so I can kind of stop thinking about that, and just go 5 times 2 would be 10, and then times 7 would make a 70 right there. X's, I'm just going to count them up. I got 5, 4, and 3, so 5 plus 4 would be 9, plus 3 more would make 12. And then y cubed, y to the 4th, y to the 8th. So let's see, that'd be 3 and 4 is 7, plus 8 more gets me 15. Next one, so let's see, double negative, so we'll just make that big positive. And then 6 goes into 48, that'd be 8 times. And the 48's up top, so this is in the top. If it was 6 over 48 with 48 downstairs, then we just have the 8 in the denominator. Here I got 6 x's up, 8 x's down, so if I cancel, I'm going to have 2 left downstairs. 6 y's up, 5 y's down, so again, canceling those, and I'll get a y. That next one, let's get this maybe combined a little bit and then kind of figure out where we are. So negative 3 times negative 12 is going to be 36 cubed into the 7th, so add those and get 10. That's going to be over this 9x to the 13. And then I can still go a little bit farther, so 9 goes into 36, that's going to be a 4 up top. 10 up and 13 down, so that's going to give me a x cubed downstairs. And this last one looks kind of scary, but it's not that bad. I think just because it's a big mess, I'm going to multiply. I'm going to combine my numerator. I'll combine up my denominator, see where that gets me, and then I'll think of it as canceling. So here I got 5 times negative 6, so that's going to give me negative 30. x4 and x2 is going to be x to the 6th. And then y and y squared, so that's like 1 plus 2 makes 3 y's up top. And then downstairs, negative 3 times 2 is going to give me a negative 6. 6 and 5 on the x's, that's going to be x to the 11th. And 7 and 1 on the y's, so that's going to be y to the 8th. 6 in the 30, so that's going to go 5 times. And 6 up, 11 down, I would have, if I cancel, it's going to leave me 5 downstairs. And again, you can always think of this 6 minus 11, and then y 3 minus 8. So there's a negative 5, negative 5, and then those should come downstairs. For me, I prefer 6 up, 11 down, and that leaves me 5 down. And then 3 y's up, 8 y's down, so cancel out 3 of them, and you'll still have y to the 5th downstairs. So I wrote kind of funny, but 5 over x to the 5th, y to the 5th. Okay, and hopefully that wraps up the longest video of the quarter.